This video will go through the properties of images created from concave and convex mirrors. We'll start with concave mirrors. In class, you should have received a worksheet that had 6 scenarios dealing with the position of objects and the images created from concave mirrors. You should use that worksheet as we go through this video. The first scenario is where the object is located at infinity. Infinity in this case is a relative term. It just means really far away compared to the size of this mirror. So for example, if the radius of your mirror was 10 centimeters, something that's 5 meters away would be considered infinity. As a matter of fact, something that's 2 or 3 meters away would probably even be considered infinity in that case. When an object is at infinity, or really far away, all of the light rays coming off that object are parallel to each other. And thus, all of those light rays converge at the focal point. And so the image is located at the focal point. For this scenario, the image is a tiny little point of light. So we don't really say that it has a size. It's very, very small. Also, we don't say whether it's upright or inverted, since it's just a tiny little point of light. But it is a real image. We could project that image onto a screen. In the second scenario, the object is outside of C. In other words, the image distance is greater than the radius of our mirror. But it's not so far away that it would be considered to be at infinity. In this case, you'll notice that the image is located between C and F. It is smaller than the object. It's inverted, and it's a real image. Taking a look at the diagram, either on your worksheet or in the video here, you'll notice that there are 3 marked lines. Marked line number 1 is the one that goes with steps 1 and 2 from the drawing ray diagrams steps. Marked line number 2 goes with steps 3 and 4. And the line that's marked number 3, that's this line right here. It's actually not an important line. So that's one that we don't draw when we draw ray diagrams. You can ignore it on these diagrams here. Moving on to scenario number 3, where our object is located at the center of curvature. You can see that the image is also located at the center of curvature, except that it is inverted. But it happens to also be the same size as the object. It is also a real image. Moving on to scenario number 4, where the object is located between the center of curvature and the focal point. In this case, the image is outside the center of curvature. It is larger than the object. It is inverted, and it is real. Scenario 5 is kind of an odd one. In scenario 5, our object is located at the focal point. Take a look at those 2 reflected rays. They will never meet each other. This is kind of an odd scenario, but it's true. It happens. When you have an object located at the focal point of your mirror, the image does not exist. There is no image. Some textbooks may say that the image is located at infinity. That's fine as well. The very last scenario has the object between between F and the mirror. We may say that it's located inside of F. In this case, your image is located behind the mirror. It's upright. It's larger than the object, and it is virtual. These 6 scenarios are scenarios that you should remember. You should memorize these. They will help you check your answer to your work when you do the math with these problems. And they'll also help you kind of know exactly what the image should look like when you're given an object and some distances. You'll notice looking over the worksheet that scenarios 2 and 4 are basically inverses of each other. Also, scenario 1 and 5 are similar to each other. That may help you remember them a little better. The other thing I want to talk about are convex mirrors. Convex mirrors don't have 6 scenarios. Thank God, right? It would be hard to remember all of that. Instead, convex mirrors always create a virtual image The image is always upright. And the image is always smaller than the object. Another thing that makes convex mirrors unique, and we'll talk more about this as we get to the mirror equation, is that for convex mirrors, the focal length is negative. That stems from the fact that the focal point is actually located behind the mirror, because parallel light rays that hit a convex mirror will never converge on the same side of the mirror. Hopefully these properties will help you understand exactly what an image looks like when it hits a curved mirror.